This is East Tennessee PBS.
Welcome out there. It's Mathline time. You are at the right place, right time. I am Ernie Roberts. I'm your host for the session today. No matter what time of day you're watching us, we're glad you've tuned in, all right? And when you say that, Ernie, what do you mean, what time of day? Aren't you always on the air at the same time? We are, but also we have streaming. We also have these things appearing on YouTube. So you can check us out anytime, anywhere you like, and we hope you will. But in the meantime, it's specialized segments time. It's summer school. It's all sorts of great things going on here at Mathline, and we want you to be involved. So go ahead and get some pencil, get some paper, maybe a little graph paper along the side on this one, and a calculator. Might not be a bad thing. All those good things, and get you a minute there to take care of it. We'll sit back, relax, and as I say always, we'll do some math. So let's see what our topic of the day is for what's going on here. Evaluation time is here. What in the world is that evaluation time? Usually I'm thinking when we evaluate mathematics, we're doing some substitutions of sorts, and then we're going to work through the operations, add, subtract, multiply, divide, and come up with a solution. So let's see if I'm right on this. How about it? Oh, it says given a function, so we are in function, and notice this funny little notation we have at the top of this. It says, looks like a fx, like special effects or something like that, you know. But what it means is the function of x. It's f of x. We read it as many times, function of x. And what happens is we have a function that we're going to work with. In this case, it says 3x minus 2. So evaluating, we're going to take each of these respective values here, 3, -1, 2/3, and we're going to replace each time and get a different y, okay? So that'll correspond to those various x's. And you say, Ernie, where did y come from? A lot of times we call that y f of x, meaning the same thing. I like the f of x. It's called functional notation. Ooh, that was fancy, wasn't it? But it simply says we have the variable x, and everything here is going to be a replacement for that variable x, all right? Makes sense? Substitution, if you will. And that's where we're going to get to the evaluate part. So I hope everybody now understands where we're going. Some of you said, I got it, finished it. All right, let's create a table. Let's first of all, and show your work, my friends. You know that your teachers like to see that. So does anyone who's looking at your work. They want to know, where'd that come from? Absolutely, that's why we do all this show your work business. So let's go to that function. It says what? F of x equals 3x minus 2. All right, everybody good so far? Got it written down? I know you're ahead of me, right? Let's see what happens if we put 3 in the place of x. That's all we did. We took x out of the work and put 3 in its place, all right? And have at it. We're going to put a 3 out here. We're going to show that substitution, show that's how this evaluation is going to take place. And remember, my dear Aunt Sally, not only is it working good for us left to right, but my dear Aunt Sally says we multiply before we subtract. So, you got it? 3 times 3 is going to give us 9. And minus 2. By the way, for those of you who are wondering, what in the world that dear Aunt Sally is, that's the order of operations. In other words, we multiply before we subtract. And my dear Aunt Sally simply is multiplication, division, addition, and subtraction, all right? And if you want to get parentheses and exponents, then we please excuse. But I digress, but I want to make sure everybody understands what's he talking about. By the way, let's finish this one off. We get a 7 out of that. So that's going to become a nice little ordered pair we're going to graph in just a second. We'll create a table after we get all our work done, all right? Now, taking the next link here, how about it? F of -1. So we're going to replace x. Everywhere we see x, we're going to put a -1 in there this time. So we're going to take 3 times -1, and we're going to subtract 2. Multiplication first, my friends. So let's do that. 3 times -1 gives us -3, and minus 2, I'm picking up a -5. Remember, it's like saying -3 plus a -2, which gives us, yes, -5. There you go. Oh, 2 out of 3. We ready for, oh no, you put a fraction in there, Ernie. Yeah, Ernie put a fraction in there. I'm sorry, guys. We can deal with it. Let's put a 2/3 in this x value. And the reason we can deal with that is because fractions are our friends, and they happen, and we have to use them sometimes. But we're going to drop a 1 under that. But don't forget, you still got to minus the 2. Still minus the 2. So what happens here? Good old fraction action. Yes, you do. Yes, you do. The 3's cancel out. We're left with, is that left with 2? Are y'all kidding me? Is that right? Yeah, 2/3 of 3. That works that way. Gives us 2. So some of you are going, 2 minus 2. That's 0. That's going to be 2 minus 2, which equals 0. Oh, yeah, folks, we can have a 0. We can plot a 0 on the graph. We're good. That is no problem. All right. So let's make our table over here. Let's get a table going here. How about it? We've got x. And remember I said x and y? Well, let's just go ahead and put f of x in there. Since we're using that notation, we understand it's a nice fancy way to write y, but it's also a great way to show what we're doing with our substitutions here, our evaluations. So let's put them in here. We got 3. We have -1. And we have this 2/3. And we're ready to put them in table form. So where we go? 7. We have -5. And then we have this lovely 0 there taking care of us. So that's interesting, isn't it? That's the 2/3, by the way, what we put in there. And are you ready to graph it? I think we're ready to graph it. So guys, let's take it away. Thank you. Boy, they're good up there. And I've got the little graph. You remember we always call it x and y. Just remember, our y is going to equal f of x up here. All right, so when we put our values in there, so it's like doing ordered pairs. Absolutely, that's what we're doing. So our first ordered pair was over 3 and up 7, which almost took us off the grid, but there you have it, all right? Our next one says at 2/3, we go over 2/3, we're going to be landing on 0. So there it is. Well, that was easy, wasn't it? And you say, well, Ernie, they're making a straight line. Well, we always make a straight line. There are 2 points, right? Let's see what the third line does, all right, or third point. We don't have a third line, that's for sure. -1, and we're going to go down to here. And you know what? That looks really pretty crisp. We can bring in Curious George to help us out a little bit. Let's see how we've got going here. Do those points line up? Those points line up very nicely, all right? And I'm not going to go any further with it there because it didn't say really draw a line there, although if we were to do the complete graph out, we would have that. But notice what we do. We have 3 points. Those are our 3 points. We're lining them up, and they are going to be linear because f of x equaling 3x minus 2 has this style, that slope and intercept business, as you all well know, and it's got that nice little linear function look because it is a linear expression. So our graph should be a straight line. If we were to connect all those points, we would have such. All right, you with it? Are we good? And, oh yes, it's definitely a function. That's why we call it f of x. Let's take another one here. A little practice time. Now you got the gist of it. Let's see how quickly we can work through this one. Again, we have our f of x starting off equaling 2/3 of x, and we're going to subtract 2 from that. We're going to evaluate for f of 3, f of 0, and f of -6. All right? Then we'll graph and do our table. And everybody's already sitting there, Ernie, I bet it's going to be a straight line again. Well, it looks linear, doesn't it? Because we have something x and a number attached to the end out there. Although you don't have to have that number attached, but if you've got x and no exponents involved, you can almost bet it's going to be a nice linear expression. So let's put it out there and see where things go. Everybody good? Oh, there's that 2/3 of 3 again. How about it? Like that? Put a 1 under there. We get equaling what? 2 minus 2, which is going to give us flat out 0. All right, so there's your first one. Yeah, 0 is okay. Some people get a little nervous when they see that, but it'll work fine. Let's take our next value. Oh, speaking of it, we'll put a 0 in for x. Well, that was easy, wasn't it? Put a 0 in there. My goodness, that's the easiest point of them all because we know 2/3 of nothing is still nothing, right? And we're going to subtract 2, so what's left? Go get rid of all that. Basically, you have 0 minus 2, which will give you that -2. Good news for us. And one more just for the road. We put a -6 in there. I kind of like to do a 0, a positive, and a negative value when it's appropriate, when we can, just to give a nice wide range. And plus, it stretches out your points, and you say, wow, they really do line up. So let's see how it goes here. 2/3, put at -6 this time, and we'll subtract 2 when we get done with the end. All right, put a 1 under there, my friends. And we got a 2 left over. It's a -2, by the way. Does everybody see that negative there? I am seeing -4 minus 2, which is going to give us what? A 6. Well, how interesting was that? And table time. How about it? We're going to put our x, our f of x, and see where we're going to go with this. And our x first value was what? We put in a 3. We have a 0. And we have a negative 6. All right? And for our values, we supposedly got 0 there. Well, it's not supposedly. We did get 0, didn't we? Evaluated correctly. We have a negative 2 here. And then, goodness sakes, we got a negative 6. The question of questions, will it line up? Will it line up? Are you ready to find out? I'm ready to find out. Let's see here if I can find one more piece of graph paper. And we got it coming here. Yay, thank you. Let's see where it works here, all right? And our points are at 3, 0. Some of you are way ahead of me on this one, aren't you? And we have 0, negative 2. Right, there we go. Remember 0, go down 2. This one says go over 3 and don't go up or down. And last but not least, we've got, negative 6 way out here. And we're going to take it down 6. Do they line up? Bring on my friend George here again. And they do. Look at that. Nicely lined up. And this time, some of you say, I really would like to see that line go through. I'm going to do it for you, all right? But we're going to still highlight that point, and that point, okay? But it does line up, and that would be for the function f of x. Remember, that's another nice fancy word for y. And there you have it, okay? A linear function. Another linear? My goodness, could we have just linears? Oh, there are other type functions. We will deal with those as time goes on this show. As you all well know, we do a lot of different things, but we're going to let it go at that point. Let's take a look at one that does not have just x, but has x squared in it here. We call this a quadratic. And this time we're not asking to graph it because these are just basically some random points we've thrown in here. And what we want to do, if we can with you guys out there, is let's just do the evaluation part, all right? So we've got f of x equaling x squared plus 3x minus the 2, all right? And right off the bat, we put a fraction in there, all right? And that's good. That's good because we need to do our fractions. And again, show your substitution. Remember, f of 1/2 means, put in the 1/2, we'll square it out, plus 3 times another 1/2, and then we're going to subtract 2. Now some of you go like, ooh, Ernie, we don't like fractions. Well, let's be careful here, all right? First of all, what do we get when we square a half? What's a half times 1/2? It's going to give us 1/4, so be sure you put 1/4. It's not 1. We don't say 1/2 times 2. Sometimes people think that for some reason. But when we square, it means a half times a half, which is 1/4, which some of you are going like, ooh, that's not as pretty as I thought it was going to be. It isn't. So we have a 3 over 2. We're just going to put a 1 under that. We're just going to leave it 3 over 2. That's going to do something for us here. That's actually 1/2. And then we subtract 2 from that. Now, I'm already going to think a little bit ahead. When we put these together, this 1/4 and 1/2, we're still less than 2. So this answer is going to be negative. It's going to be a negative situation. So let's think about it. Let's work this thing out. 1/2 plus 1 1/4, that's going to give us, not 1 1/4, but 1/2 plus 1/4, gives us 1 3/4. We're going to subtract 2. That's going to give us a negative 1/4 right there. So there's our first value, 1/2, 1/4. Those are kind of small fractions, aren't they? And by the way, be sure you get that negative on that 1/4, all right? We don't want to leave that off. Now, where does it go from here? Hopefully it gets a little bit easier. Well, we got to watch our signs with the negatives, don't we? So let's go to f of negative 2. And that's going to give us negative 2 squared plus 3 times that negative 2 minus 2. All right, working through. Folks, notice I put a parenthesis around my negative 2 and we square it because that's going to give us a 4. All right. How about it here? We're going to multiply. It's going to give us minus 6. Very important. That one is a negative. And we keep our minus 2. So looking at all that going through there, I've got 4 minus 6. Well, we got that under control. It's like saying plus a negative 6. So it's negative 2. We'll subtract 2 more. We're going to end up with negative 4 on that one. So back up here, we had a negative 1/4. Down here, we have a negative 4. Yes, there's a big difference, isn't there? So be careful that you understand fractions are our friends, and they tell us they're parts versus full fours there, all right? So let's see what happens with the 3. F of 3, positive one. I think this was the easiest one probably, isn't it? So we've got 3 squared plus 3 times, oh my goodness, another 3, and then we'll subtract 2 from that. Everybody see our substitution there? Go back to here. Put in 3 everywhere you see an X. Wow. And we have 3 squared, which is 9. 3 times 3 is 9, and we're going to subtract 2. You know what I'm seeing? Everybody seeing, I hope? 16 on that one. So that one got kind of crazy. That's another reason why we probably weren't going to worry about graphing this one, because the numbers start getting big rather quick. But that's what happens when you start squaring values, and you start squaring numbers that are rather large, okay? You start getting experiences of higher values. But let's face it, not all math is between 0 and 10, or in this case, on my graph situation, sometimes between 0 and 7 or 0 and -7. So again, there we go. Functions work. You don't always have to graph them, but understand there is a relationship going on here. We call it quadratic, and if we were to graph all the points, we would have what we call a parabola. So let's move on to our next one. How about it? Let's do some things called composite fractions, where we've got an f of x and a g of x. Now, folks, don't get excited. It's just 2 different values that we're looking for, 2 different expressions, and we're going to evaluate them, and we're going to blend them together. We're going to put a plus right. Everybody see that? So let's take a look at, first of all, we're going to say f of 1, which should equal what? It's 2 minus 3 times our 1. Okay, well, that was pretty easy, wasn't it? In other words, we choose the f function because it's indicating. Go with f of 1, all right? Now, let's go to our second function, which is 2x squared minus 3x up here for g of x. So again, f and g are just 2 different functions. Don't get excited. We can put little letters all to our heart's content in front of those x's, and you'll see that a lot in your algebra problems and pre-algebra problems. So let's go to our next one here. G of -2. What does it equal to? And by the way, you want to go ahead and evaluate that? I think we should go ahead and evaluate that. Remember, we multiply first, right? Then we subtract. So it's going to be 2 minus 3, which equals that -1 value. There you have it. Now, how about our next little guy here? We got a 2, and we're going to put in a -2 and square that. Oh, some of you are going like, that must be that please excuse part, or that parentheses exponent moment. Yes, we've got that coming our way. Minus 3 times -2. Woo! Anything else? That's it, isn't it? All right. So now this time back up here, remember, this one was pretty easy, right? This one, we've got the minus 3x again. That's why we had that minus 3 times the -2. So let's make sure that we're doing that correct. Everybody see that? So square, do that first, then multiply by the 2. We'll do subtractions at the end. So squaring a -2 goes positive. So it looks like we've got an 8 there because what? 2 times 4 will give us 8. Let's go ahead and multiply these little guys. I've got a -3 times a -2, which is going to make things go plus. So I've got 8 plus 6, which should equal, cram it in there, 14. So what's the story? We're just going to simply say -1 plus our 14. So what looked a little bit complicated at the beginning with 2 things, once we put numbers in there, it become very easy. Now, quick check. We're going to get what? Lucky 13? I think we're lucky if that's the right answer. Again, go back up here and let's make sure we didn't make any careless mistakes. Remember, you multiply, then you subtract. Now, if you'd said 2 minus 3, you would have lucked up because you were multiplying by 1, okay? You would have still gotten -1. But the rule is, go there first. So be careful on that. It would have been different had we not used the number 1. Another thing here, again, square. It's going to be a positive 4. Watch your sign. I said it so many times, but I want to make sure we're all good. And we get an 8, and then we had, oh my goodness, size changed again. So we got 14. Putting it together, there's where we end up. So it's not hard, is it? Just identify. That's why we use these little letters in front, the little f and the little g, so we know which one to go to, which one to use. It's like a little cataloging system, so to speak. All right? Good enough? Are we ready for another one? I think we are. All right, let's check and see here. Oh, looks like the same function's coming at us again, just a little bit different valuations, but this time we're going to subtract our values. So it's a little practice time here for us, my friends. So let's talk about f of 6. What are we going to use? we're going to use the f function, right? So that's going to equal 2 minus 3. Oh, goodness, we've got a 6 there. Everybody good so far? See what we did? Just simple substitution, right? Now, over here, let's go ahead and figure out what g of, what do we got there? Negative 2. That sounds familiar, doesn't it? That's what we used the last time on our problem. So let's make sure we can do those signs one more time. How about it? We've got a 2. We've got a negative 2 going in there. And by the way, show that substitution. Very important, very important. Minus 3 times your negative 2. Everybody good? Oh yeah, you say, Ernie, are you going to evaluate f of 6? Are you going to evaluate? Yes, we are. Yes, we are. So that's going to give us what? 2 minus 18, which gives us, I think, a negative 16, right? Your 2, you take away 18, you are in the hole big time. You're in the negative. Or you can say 2 plus a negative 18, and you still get, how about that, negative 16. Down here, let's see if we can get it the second time again. Square that negative 2. Gives you 4. Multiply by 2, you get 8. And, oh yeah, negative 3 times negative 2, you're going to get a 6. And we got a 14 coming up there. Time to do the subtraction moment. Now, let me point out to you, we found the individual functions. Now we take those values and subtract them. So how about it? We have a negative 16. We shall subtract that 14. And I believe we got a negative 30 coming our way. Is that what checked out with you guys at home? Great job out there, all right? And there you have it. That's our little composite function for the subtraction. I wonder what else we've got heading our way here. You never know, do you, on Mathline? Let's take a look at our next problem here. It says, whoa, simplify. Those functions sound familiar. We're still working with the same ones. Good. That makes it pretty easy. And we're still going to play with that g of negative 2. But my goodness, what in the world does this say? Simplify f of g of negative 2. Is that a mouthful or what? Wow, that's crazy, isn't it? Well, what this tells me, it's kind of like parentheses, only we got a nice little bracket because there's a parenthesis. So we're thinking, everybody thinking out there, hope with me, we need to go here first. So here's what we're going to do. We're going to start with, what is the g of negative 2? And everybody goes, Ernie, we found the g of negative 2 now. 3 problems in a row if you're watching this whole show, all right? So it's still going to give us 14, but one more time, let's practice it out. 2 times negative 2, raise it to the second, minus 3 times that negative 2. Yes, we still get 8. Everybody remember that? Square that negative 2. Some of you may just be joining us, all right? Make sure you do that. Plus 6, we get 14. Life is good. It's nice to get 14 each time, isn't it, when you're doing the same process? Now, what's the next hint? The next hint says now we're going to take that g of negative 2, which we have at 14, and we're going to plunge it right in there. Evaluation time, and it says simplify, but we're actually going to be able to evaluate. So here we have it. 2 minus 3 times, oh, you got it, 14. Wow, that gets kind of big, doesn't it? And are we done? Well, we got to figure out what we got, right? 2, do your multiplication. 3 times 14 gives us a minus 42. It looks like negative 40 is where this thing ended up. Wow, went one direction toward 14, then all of a sudden we got a big number coming back, right? That's how the functions work together, all right? And again, composite functions, nice code word for these type problems. And how about it? Let's switch them around. You say switch them around, Ernie? Yeah, let's do f of 2 and see what we can do for g, all right? So first of all, let's go through here and figure out what we've got. So we've got f of 2, that's our first part, right? Remember, we're going to work this from the inside, go to the outside. So we've got 2 minus 3 times 2, which basically gives us 2 minus 6, which I'm getting negative 4 this time. Everybody nod with me, agree with me. That's not a negative 2. We didn't throw you off there, all right? Now, what we want to do is figure out what is the g of, hey, something different. Yay, negative 4. Going to work that out. 2 times, put a negative 4 in there. Let's square it. And we'll get it right. Subtract 3 times that negative 4. Or just say negative 4 times negative 3 will work out either way. Watch your signs. I always keep saying that, but we definitely want to watch our signs here. It's going to give us 16 times 2, which is 32. Everybody see that? Negative 4 times negative 4, positive. And we're going to add, whoa, a little bit more here. How about adding 12? And I'm checking out at 44 right there. Again, steps, work to the inside. Find f of 2 first. There's your f function. Work with it. 2 minus 6 gives you -4. Now, take that response right there, that -4, one more time, into your g function. Your g function's up here, all right? Boy, it gets kind of crazy, doesn't it? And you've got 2 times -4 squared, and got to put the -4 in there also. So again, we squared it, got 16, doubled it, 32. This part worked out to be plus 12. You know the last thing we're going to do is add them together, and we get 44. Checking through. That's the story. Composite functions a little bit. We did a little bit of evaluation of a linear function. This is a quadratic, by the way. Mix them together, all sorts of fun things can happen, all right? And folks, thank you for tuning in. Hope you had some fun with our functions today and evaluating them. We are going to be back at summer school time. We're going to be around a little bit longer with that for sure. And we will see you again next time.